Hello, what's up, YouTube? Good morning, everybody. We are continuing the Khan Academy SAT problems being solved live on camera. What's up, Instagram? Same thing. We're going to be solving SAT problems live from Khan Academy, which are the best, most high quality SAT problems you can find. And why do I say that? Of course, the SAT is made by the College Board, but the College Board and Khan Academy have partnered. And I recently went to a talk by the College Board where they said, hey, they gave a lot of supervision. They watched over the problems as they were being created by the Khan Academy team, and they sign off on them. So these are top-notch, good sample problems. And we're going to solve them. We're going to get the hang of everything. So today we're next in the next category is units, and I have not seen them yet. So let's see what they're all about. Switching over to shared screen again on Instagram. If you're watching, go to my YouTube channel. Go to YouTube, search for Scalar Learning, and you can find the live stream. You can see the problems I'm solving live as opposed to just watching my face and hearing me talk, which I don't know. Some of you may prefer. You don't want to actually see the problems. I've seen people say that in the comments. It's up to you. All right, here we go, jumping into units, and let us begin. Boom. Oops, where's my screen share? Sorry, that was my tutor, one of my tutors on the screen. All right, so here we go. We have got unit problems. Oops, desktop. All right, and begin. While driving with his father, Amit holds his breath. Indian name. Amit holds his breath whenever they pass through a particular tunnel. Amit counts the number of seconds he holds his breath from the beginning of the tunnel to the end of the tunnel. This is really strange. And finds that he holds his breath on average for about 8 seconds. Okay, let's write some of this down now. 8 seconds. If his father drives the car at 60 miles per hour through the tunnel, according to the average time Amit holds his breath, how long is the tunnel? And they give us this nice 5,280 feet in a mile because we're doing this in miles. Okay. So let's think about it like this. We go 60 miles in 1 hour. You know what? Let's straight up convert this to, well, whatever. Let's at least convert this to minutes. 60 miles in 60 minutes. Okay, this is a calculated problem, by the way, so we could use a calculator, which is the same as going 60 miles in 3,600 seconds. Okay, so now we've got an idea of how many miles we go in whatever, in an hour. We can start to break this down. We can be like, okay, well, now I'm going to simplify. We're going to really break down this rate. This is now 6 over 360, and we could divide it again, and it would be what? 1 over 60. 1 mile over. Oh wait. This is 60. What did I do here? Let me just make sure I did this right. So 60 miles in 60 minutes, right? Did I do this right? Yeah, 60 miles per hour, and then we're doing 60 miles in 3,600. So then 6 miles. Yes. Okay, here we go. Whew, all right, I get confusing myself. 6 miles in 360 seconds. 1 mile in 60 seconds. There we go. All right, so 1 mile in 60 seconds. That means, and then now I'm going to convert the top to feet. 5,280 feet in 60 seconds. Okay. Now, why did I do all of that? I did all of this because I'm trying to boil down the rate as much as I can so we can start to get something in. I'm doing a bit of a long way, but I'm hoping that you're going to see the logic behind this. Once we can get this down to somewhere around 8 seconds or 1 second, then multiply by 8, we can get our answer. Now we can break this down, right? We'll cross off those zeros. Now we got 528 feet in 6 seconds. So this is actually pretty good. We could actually divide this, and we could have divided it up here too, and gotten our unit rate, right? You just take 528 or 5,280, you divide it by 6. You get your unit rate. You get the number of feet you go in 1 second. I'm going to already estimate. Well, let's just go ahead and do it. I'm going to do it up here without a calculator. It's fine. 6, so that's 7, 8, 9 is 848 and 8. So we're going 88 feet per 1 second. Multiply the top and the bottom by 8. And did it say approximately? No, it didn't say approximately. So I guess this should be exact. No, this is going to be approximately. According to the average, about how long is it? That is approximate. Okay, so now we're multiplying, and then we're going to get 8 seconds on the bottom. Whatever we get on the top, whatever we get on the top is our answer. Let me try and do it mentally. 64 plus 640 is 704. So it's 704 feet. B is our answer. All right. If this seems crazy, what I just did, which hopefully I wanted to do it so you'd understand it a little bit better. The straight and narrow of it is at any point, once we got to this point, once we got feet over seconds, you can just divide, get your unit rate, use a calculator, you would have gotten 88. Then you multiply it by 8. So anyways, to make sure we're right, you never know. 700, I think is what I said. Yeah, it's good. All right, let's jump to the next one here. Let's see what we got. Which did units recently in my pre-algebra class. Not too long ago. A grocery store normally sells lemonade for $3.50 per bottle. The grocery store is currently having a sale on lemonade. So $3.50 per bottle. The grocery store is currently having a sale on lemonade, which advertises 6 bottles. So $13.50 per 6 bottles. All right, just rewriting everything, get it in my brain. How much cheaper is the lemonade on sale per bottle than compared to the normal price? Oh yeah, because this is the sale, right? Well, we already have this metric, right? We need to figure out what this is per 1 bottle. $13.50 per 6. Again, this is just a division problem. You can think about it like we just carry it out. $13.50 divided by the denominator 6 will give us our unit price. The other way to think about it is we can simplify this fraction by dividing the top and bottom by 6, because then that'll take this denominator to 1 and the top to whatever it takes it to. So either way, whatever works for you. Let's do it up here. Again, this is a calculator problem. If you even got one on you and you're following along, just carry it out. See, it's easier. Like I've said before, I just like doing it this way to keep my math skills sharp. 12, 3, and then 5. So $2.25. So $2.25 is the price on sale compared to this. And then it's just a subtraction problem. $3.50 minus $2.25, I'll put it down here. It's 1.25. And that should be B. Let's go back to see if we are right. Yeah, it's good. It's good. And thanks, guys, on Instagram for watching. You're probably just hearing me talk about these problems right now. If you actually want to see me solve these problems and not just watch, you can go to my YouTube channel, go to YouTube, search for Scalar Learning, and you can see the video where you can actually see the problems being solved, not just hear me explain them, which I think might be better. So definitely check that out. Let's go to the next problem. Question number 3 of 5. I think that is pronounced, is it Joao or Yao? I don't know. Is looking for an apartment to live in. He finds 4 available apartments. He then records the monthly rent and size of each apartment in the table right here, as seen below. Based on the information in the table, which apartment has the highest cost per square foot? Okay. We got to calculate the unit cost of all of these guys. Maybe some of you guys could eyeball this and estimate. If I had to guess, I would say St. Clair Road. This looks about right. It's a different, it's $750 per dollars per 500 square feet. I think that's about right. Now I can do this math in my head. Probably, let me just see, 5/4. So this is, okay. Anyways, what we're doing is we're dividing the rent by the size in square feet. We're getting, because whenever we're trying to get money per, let's say square foot, per something, we divide by the thing after the per. Okay, so it's like, this is $500 per 400 square feet. We just do 500 divided by 400, and we get the unit rate. So what this unit rate is 5/4, which is 1.25. $1 at 1.25. Let's do the next one. 600 over 450 That is 1.33. You can use a calculator on this. Like I said, I'm just doing this in my head. And then this one is, the next one is 750 over 500, which is 1.50. And then 800 over 550. This one I may need to think about for a second. Wait, 250. So 1 and then 250 over 55. It's like this, because you end up with, the way that I'm doing these fractions, it's 800 over 550. So I know we take 550 out of 800, it would be 1 and 250 over 550. I'm just going to cross this off, and then I'm going to carry out the division. And it's, well, it's actually 5 over 11, but this is fine. Actually, let's do that. 5 over 11. And then it's 4, 6, 0, 5. Oh, I think this goes 4, 5, 4, 5. Anyways, it's approximately 4, 5. Okay. Which one's the most expensive? Highest cost per square foot. Okay, like I predicted, St. Clair Road. And that's it. On the real SAT, even though I had a pretty good hunch that that was right, I would have never guessed and said right off the bat and answered that, unless I was in a really tight time crunch. Never would have guessed. I would have still worked it out, made sure, and then answered. Because you always want to do that. If you have the time, verify. It doesn't take that long to actually do the division, especially if you have a calculator. You could, I suppose, eliminate like a couple of these. I mean, or maybe the first one, 500 over 400. That's probably you could cut out, but I would play it safe. Hey, how's it going, Mona? Thank you for joining on Instagram. Okay, here we go. Question 4 or 5. Next, the strength of a magnetic field is measured in Teslas. 1 Tesla is equal to 1 Weber per square meter as follows. All right, so here's Tesla. Here's Webers, I guess. Divya is building a circuit for her physics class. Point P on her wires, on one of her wires, has a magnetic field strength of this. Webers per square megameter. Webers per square megameter. Got it. Okay. Where 1 megameter is equal to, so 1 megameter. I don't know what the term is. Let's just call it like mm for now. 1 mm equals 10 to the 6th meters. And I think 10 to the 6th, what is that, a million? So it's a million meters. And what is the magnetic field strength in Teslas? Okay, so we got to plug it into this guy. 6. Okay, so let me get this straight. This is a lot of craziness going on. See, these ones, in my opinion, they're quite convoluted, right? Because of all this technical jargon. But we got to decode it, and I got to decode it. It's even a little tricky for me. So Divya is building a circuit for a physics class, and then it has a magnetic field strength of blah, blah, blah. 6 Webers. Oh, I see. Okay, so it's the Webers is on top is 6.10 to the 6th on top over per square megameter, where 1 megameter equals 10 to the 6th meters. So per square megameter, and wait a minute, it's just like this, 10 to the 6th. Oh, I think it's B. Unless I did that wrong, because a square megameter is 10 to the 6 meters, unless my only worry, it could be this guy. Because here's where I'm a little confused, because it's saying it's equal to 1 Weber per square meter. Now, do I have to square the value in the meters? Meaning, is this become 6 times 10 to the 6th over 10 to the 6th squared? I don't believe so. I don't believe that exponent applies to the value, because this exponent just applies to the unit. It's in meters squared. So, because it's saying per square megameter, where 1 megameter equals, oh, you know what? I think we do have to square it. Because if 1 megameter equals 10 to the 6th meters, okay, I think we, to get a square megameter, we have to square it. So you know what? I'm going to revise my answer. I'm going to say it's 10 over 10 to the 12 fifth squared because these exponents multiply. Uh-oh. These exponents multiply. My Instagram feed just crashed. And then these guys subtract here, and we get 6 over length to area, and that's why we had to square that value. Keep seeing my tutor Greg there. All right, here we go. Next and final question. What's the time here? I think 6:35. Oh my God, I gotta go. See, this is the problem in the mornings. I gotta go to the gym, then I gotta go to school. Question 5. The table at left gives the total bone area in square centimeters and bone mineral content in grams of 4 healthy people. Okay. Right there and right there. Bone mineral density is the unit rate of grams of bone mineral content per. Remember, I said that's the key of square centimeter. Whenever we're doing per, that means whatever is the square centimeter, or whatever comes after the per goes on the bottom. So bone density is going to be mass 2520, just as the top one as one example over this. Okay. Which person has the greatest mineral density in grams per square centimeter? Which one of these is going to give us the biggest value? That's the translation. I am going to do a little bit of elimination here. I can tell that 2520 over 2160 is definitely bigger than this one. This only has a small differential of 180. So I'm going to cross that off. I'm pretty sure that's not going to be it. And this is where a calculator would really help because these are a bit more difficult numbers. I'm going to do my best and try and see if I can eyeball this. And then if I really need to, I'll use a calculator. I'll just load one up on my computer. So then we've got the next one is, what's this differential here? It's like 40. I think I already see the one that it's going to be. It's going to be, I think, either person 2. I think it's going to be person 2. So we got 3010 over 2400. I'm just going to cancel these off. And this has a differential here, see, of 59. You can't just go by the differential. It also depends on how big the denominator is. And then we got this one over here, which is 2460 over 2050. And this one has a differential of 41. And when I say differential, I'm looking at the difference between the numerator and the denominator. So this becomes 246 over 205, 301 over 240, 252 over 216. Okay. So what you'd want to do then is you'd calculate it. You know what? I'm going to do it. I'm going to actually use a calculator here on my computer because I don't have one with me. But let's get the exact results. So I'm guessing it's going to be 301. What is it? Person 2. So I'm guessing it's going to be B. Let's make absolutely certain. 252 divided by 216. 252 divided by 216. 1.16. Say 1.167. So person 1 is 1.167. Person 2, 3010 divided by 2400. 2400, right? 1.254. 1.254. Ninth doesn't even do C. 1980 over 1800 is 1.1. Just so you can see it. And then 2460 over 1250. 2460 divided by 2050 is 1.2. Now we can literally see we got the unit rates. Now we just stack them up. This guy's way too small. This guy's too small. And this guy's too small. B is our answer. Let's go with B. Select it. Yeah, it works. They got the same numbers you see down here as well. So that's it, guys, and thank you so much. Oops, let me jump back to my non-shared screen. Unshare. Was that on share screen or not? I clicked share screen. Okay. Now I'm worried that I've made a big mistake as I've been recording this because it just said no camera. It didn't say share screen. So I don't know what happened there. If this didn't work, I'll do another set of units tomorrow and I'll just erase this video, I suppose. It'll be the first time I had to do that. But I hope I did share screen correctly. So I'm going to check it now right after this. But anyways, thank you guys so much for joining. I hope that was enjoyable and I hope that was helpful. You can email me if you have any questions, but more at huzaifa@scalarlearning.com. But more important than that, make sure to subscribe to my channel so you can get the feed and you can watch these problems and review for the SAT every day, Monday through Friday. And moreover, like the video if you liked it. Thank you guys so much. Have a great day.